Thanks, Randy. Thanks, everyone, for coming back after lunch. This session is going to involve a lot of demo and you guys doing some hands-on work. So I encourage you, if at some point you get lost, please, or you have questions, please just unmute and give me a shout out because I don't want to leave people in the dust as we go through some spreadsheet work. And I'd like you to be able to follow along. And I know I'm not going to be able to monitor the chat myself, although I know Randy and Sarah and Jim will have that covered. But feel free to unmute, ask questions as we go. I'll go ahead and start sharing. Okay, let's do from the beginning. So we're going to be talking about current conditions here this afternoon for the next hour or so. And my goal is that by the end of this, you're going to understand what the succession classes are and to be able to classify them. So we are going to get a little in the weeds here, but there is no better way to understand succession class than to actually do it in a spreadsheet. So you do this once and you'll understand it and appreciate it at a whole new level. And then we will calculate current condition percent after we've classified the succession classes. I have a couple of take-home messages for you. The rules matter, and I hope that you're going to see that as we go today. And my second message is think about what's mappable when you're modeling because it matters. And it'll impact departure. Okay, coming back to our Veg departure workflow, we're right here in this little cylinder, I guess is what you call that shape, calculate current class percent. So you've seen the BPS models from Randy and the ecosystem extent. Jim touched on summary unit. And the other key piece that you can see filtering into current class percent here is this thing called structural stages, which we also call succession class. So this little circle looks really simple. And in fact, it's not really very simple. There's a whole lot behind it. If you drill in on succession class, what that is and how it's mapped is through a spatial combine of various layers. You take your biophysical setting and you spatially overlay it with the existing vegetation type, cover, and height. And when you've done that spatial combine, you can then apply a set of succession class mapping rules to classify those succession classes. So this is the process of succession class mapping. We're going to do an exercise today where I've done this overlay for you. And I've got a spatial combine in a spreadsheet, and we're going to apply the mapping rules to classify those states and calculate current percent in each state. We're going to be using the SAGE step model. You've seen this before from Randy. So there are 3 reference states, a steppe, a shrub steppe, and a shrubland. We'll also be responsible for classifying uncharacteristic, which can include things like cheatgrass, exotic species, and invasion of trees or tree encroachment. Okay, so that's my little overview. And now what I'd like to do is have everyone open up the exercise worksheet. It's called Exercise Current Conditions. I'll remind you of this box folder. And under day 1, current conditions, I've got a few things I'll be referencing here, but in particular, exercise current conditions and LANDFIRE succession class mapping rules are going to be key to this exercise. So I'm going to do a little overview, and then we're going to work through it together, and I hope you can follow along. Okay. While people are getting the spreadsheet up, the exercise spreadsheet, I'm going to show you where we're at. I have calculated, as I said, the inputs for succession class mapping for a little landscape here in Southwest Idaho. So you can kind of see we're in the Northwest here. And if you zoom in, we're south of Boise at the Saylor Creek Air Force Range. And I just chose this randomly because it's a polygon that I could grab and it's largely dominated by the sage steppe biophysical setting. And here's kind of a more zoomed in, your little landscape here. So the exercise comes from this particular place. Okay. So I'm not hearing any issues with getting the spreadsheet, so I'll go ahead and dive in. First, I'm going to give you an overview so you understand a little bit better what this worksheet is. Let me get to the top of the page. First, you might notice that there are hidden columns. Don't unhide them yet. They're supposed to be hidden. We'll do a big reveal at the end, and you'll kind of blow my moment there if you unhide those now. So leave them hidden. The first column you see is count. That's a count of the 30-meter pixel cells. Each row represents a combination of those inputs that we looked at before. The biophysical setting model, existing vegetation type, cover, height. Okay, and we'll get to this S-class in a minute. Okay, so count is one way that we're going to be able to summarize current conditions when we've classified everything, because we can add up these pixel counts. The next thing, column B, is biophysical settings model. This is the model for the sage steppe biophysical setting. And you can see we've only got one. So we're only working on current conditions for this particular biophysical setting on the Saylor Creek Air Force Range in Southwest Idaho. Here's our BPS. Its official name, Intermountain Basins, Big Sagebrush Steppe. This is the existing vegetation type name. We've got quite a few existing vegetation types on this landscape. And then you're going to see columns G and H. We've got cover and cover class. LANDFIRE now delivers its cover data in 1% increments, but for S-classing, we group them into classes with 10% breaks. Okay, so I just wanted you to see that there's finer resolution below what we're going to S-class with. So I'm going to go ahead and highlight column G, and you can do this too. And I'm going to hide the cover. So I'm only looking at cover class because that's going to simplify it when we start to classify the succession classes. Now column I and J relate to height. It's the same story here. Height is mapped in finer increments than those at which we S-class. So column I, you can right-click on and hide that. Go ahead and hide it. And you're just left with height class. And these are the class breaks that we S-class with. I'm just going to give you a little peek. They vary by life form. So there's different heights for herbs, shrubs, and trees. Okay, and then our last column, a reminder here, don't unhide these hidden columns, just leave them the way they are for now. The last column is the S-class column. So when you look at this combination of things, this biophysical setting, this existing vegetation type, cover, and height, what are we going to call it? Okay, and our exercise is going to be to fill in the blanks in this column. You can see that there are some blanks here, but I have gone ahead and generously pre-populated some of the S classes so that you don't have to do those, okay? And so the classes that I classified are what we call non-reference states: agriculture, barren or sparse, and developed. Those classes are not included when we calculate vegetation departure. We kind of write those off. We're looking at departure in semi-natural areas. And so we're not going to try to include a departure score for ag lands or developed. We're just kind of saying, okay, that's gone, what's left, and what's its departure. And I will show you, just as an example, we choose the developed S class. You can see the different existing vegetation types that are considered developed. So you've got, maybe some housing and medium or low density, you've got developed roads, and sometimes these classes, these temperate, developed, herbaceous, that might be parkland, something like that. Okay, so we want to select all the S classes. We don't have anything filtered out here. Okay, now you need the rule set. This is your big combine. Okay, you know all the combinations of type, cover, and height on your landscape. Now you need a rule set. Okay, that's where you're going to open up our second spreadsheet, which is called LANDFIRE Succession Class Mapping Rules. This is all available on the web for people who want to go real deep into this stuff. These are the rule sets for mapping every combination of type, cover, and height for every biophysical setting in CONUS and Alaska, the conterminous US and Alaska. There are a number of tabs here. I'm not going to go into all the details. You can ask about it later or explore it later on your own. What I want to go to is this reference rules tab. So if you're following along, you want to be in the succession class mapping rules Excel spreadsheet, and you want to be on the reference rules tab. And the first thing we're going to do is we're going to filter for the rules for our particular biophysical setting. So in column B, BPS model code, you're going to use the drop-down menu, and you're going to click on select all, which will unselect all of the biophysical settings models. And you're going to scroll down. The biophysical setting model that we're interested in is 11250. So that's almost halfway, not quite. And you want 11250_6. And I'm going to pause here and hopefully let folks follow along. And if someone needs some help, just give me a shout out. Okay. So once you've selected your biophysical setting, you hit OK. And here we've got a manageable set of rules. Okay, we're down to like 10 rows, and this is something we can work with. This is how LANDFIRE, the rule set by which LANDFIRE maps succession classes. And we do it in an automated fashion, but our exercise here today is going to be to do it by hand because you'll really appreciate it at a deeper level. The first thing I'm going to show you is that there's a column. Well, here, let's do a more general overview. You've got your model, you've got the life form. It can be either herb, shrub, or tree. And there are height classes associated with each life form. And then cover classes in 10% breaks from 0 to 100. And there's some additional information, but we won't go deep into that today. Okay, so our rule sets are really based on height, and they're based on cover primarily. I am not highlighting the 0 to 9% cover category. You see in column G, 0 to 9% canopy cover. We include that information in the succession class mapping rules because some people may want to use that information at a local level. LANDFIRE does not map less than 10% cover of herbs, shrubs, or trees, whatever the dominant life form is. We consider that barren or sparse. But you might map it at a local level and you'd have some information about it here and how to classify it. Okay, so those are our rules. And what I'm going to try and do is put our rules over here. And I am going to bring up our exercise. And I'm going to put that right here. I'm going to shrink down some information we don't need. We don't really need the biophysical settings model or name at this point because we know we've already filtered for our SAGE step. And what we're interested in is classifying these combinations for cover and height, and we're going to label the succession class in column M. The first thing to do is to go to column M, and we're going to click select all. It'll unselect everything, and we're just going to select the blank rows. Okay, I'm going to point out something I meant to go over before, but you see this UE, I forgot to go over that. That stands for uncharacteristic exotic, and that's classifying all the exotic EVTs on this landscape, and there's quite a few. So actually, I'm going to demo that really quick. You guys don't have to do this, but I'm going to show you what gets classified as UE. And it's a lot of pixels on this landscape, as you might have guessed. if you know something about it, but it's not actually very many types. So automatically, these existing vegetation types, these introduced annual types and ruderal types get put in uncharacteristic exotic. So that's what that is. And that'll be important here. Okay, so we're back in column M, S-class, and I want you to just select the blanks because we've already S-classed these others, and we're gonna S-class the blanks together. Well, we'll do a couple together, and then you get to do a couple on your own. The first thing we wanna do is to classify A together. So here's succession class A in the rules. You can see that A is defined as herbs 0 to 1% height. Excuse me, not percent, meters. So less than 1 meter in height and less than 60% in cover. So on your exercise, we're gonna go first to height class, and you're gonna select herbs that are less than 1 meter in height. And that's 2 classes, herbs 0 to 0.5 and herbs 0.5 to 1. So this is going to give you all the rows that meet the height criteria for succession class A. Okay, so I've selected under height class, I've selected herbs less than 1 meter in height. I'll click OK. And now I need to get the cover. So I'm going to go to column H, and I want herbaceous cells that had a pixel cover of less than 60%. And actually, that's all the classes here. So we didn't map anything with greater than 60% herbaceous cover on this landscape that wasn't already S-classed. Remember, we're just dealing with those blank rows. Okay, so again, under cover class, you can just leave all of the choices selected. Okay, we have now filtered for all the rows that meet the cover and height criteria for succession class A. So over in column M, where it says S-class, you're gonna put an A and you're gonna copy it down the entire column. So we're manually assigning each of these combinations to S-class A because they meet the defined criteria for height and cover. Okay, now we're gonna do one more together, and then I'm gonna leave you on your own. I am going, let's see, how's this gonna work? I wanna go back let's do it this way. Under cover class, oh, we've got this, sorry. Under height class, I want you to go back and select all. So we're gonna get back all our heights. Okay, here we go. So now your spreadsheet should only be filtered on column M, and you'll see that you should have only blank rows selected. Also notice, let me make this bigger, in your rules, if you had herbs less than 1 meter tall that were greater than 60% cover, those would be considered uncharacteristic native. So these are native species because they didn't go into the exotic class, native species, but the cover is higher than we would expect. And we call that uncharacteristic, but we didn't actually map this amount of herbaceous cover. So we don't have to deal with that here. We do, however, need to deal with, also we didn't map any herbs greater than 1 meter tall. So we're not meeting this criteria for succession class B either. But we do know that we've got some shrubs left, and we want to classify the shrubs that are in class B. And B is narrowly defined here. It's shrubs of any height, and they're 10 to 19% cover. So on our spreadsheet here, we can go to the cover class dropdown, column H, and we're just going to select shrub cover 10 to 19%. And you can see if you look at your height class drop down, that includes a range of heights, but that's okay because any shrub height is acceptable. It's the cover of the shrubs that matters here. Okay, so all of these rows meet the criteria for succession class B. So I'm putting a B in column M, and I'm going to copy that all the way down so that all of these selected rows are appropriately classed. We've now done class B. Take off the filter on cover class. Go ahead and select all in column H, cover class, select all. Okay, you'll notice in column M, S class, you're back to just the blanks. That's perfect. That's the way we want it. Okay. Now your job is to classify class C and the remaining uncharacteristic native shrubs and trees. If you have questions, you can put them in the chat or you can just shout out. But I'll stop talking for a minute and we'll take 5 or 10 minutes and you see if you can complete S-classing here, putting in the information for class C and for uncharacteristic native. I'll stop sharing. When you think you're done, go ahead and unfilter everything and make sure that you don't have any blanks in that S-class column. So make sure you don't have any rows or combinations that didn't get classed. And when you're done, put a fun emoji in the chat, and that way I can track what proportion of the class is done. So we won't wait too long, or we won't go too fast. Okay. We will push on. Let me share, and now's the moment for the big reveal. I didn't do this myself, so I'm going to have some blank rows, but what you want to do is have your spreadsheet unfiltered. And now we're going to do the big reveal here between columns J and M. You get your little cursor that looks like mine with the 2 arrows, and you're going to unhide the columns there. One is VDEP, which actually we don't care about, and it's not even right for this landscape because that's LANDFIRE's VDEP. So I'm going to go ahead and rehide that, get it out of the way. But in column K now, you should have LF, LANDFIRE _ S class. And this is how LANDFIRE classified it according to the rule set. So what you want to do is see if LF S class matches what you put down for S class to see if you did it right. So go ahead and take a minute, see if you S class correctly. And if anyone had issues and wants to share, you can go ahead and speak up and we could talk about that. So I'll give you a minute or two to look at that. So that is manual S-classing, and all this is done for you in LANDFIRE. But if you're going to, say, use a different, replace biophysical settings with your own local map, you're going to have to redo succession class mapping. Or if you're using your own mapping products, you're going to have to redo succession class mapping. If you're mapping, if you want to use a different summary unit, you have to re-S class. Okay, so it's important to know how it's done and that there are tools out there like the succession class mapping rules that you can use to go through this process. So once these are all classified, you can rejoin this table back to your ARC map, map of the landscape and get a map like this. Let me zoom in here. These are the actual succession classes as mapped by LANDFIRE on this landscape. And I'm just putting a little mask here. There are some BPSs on this landscape that are not sage steppe. So anything that's black is not sage steppe. But you can see most of the landscape is, and you can see that most of the landscape is either in class A, or it's uncharacteristic exotic, or it's uncharacteristic native, which is usually, that's tree encroachment. So we can already kind of get a sense when we map this of the condition on this particular landscape, and it's looking pretty departed. But we actually need to calculate the current class percent. That's our goal here today. So let's go back to your exercise spreadsheet. If you have one, or you can just follow along on the screen and go to the pivot tab. I've built this pivot table, and it's just summarizing what we've already S-classed. So I've got the count field here, sum of count as the values, and I've got the rows as LANDFIRE S-class. You could put in yours if you want, if you're feeling confident about your work. And so we're seeing the count of pixels that are in each of these classes on our particular landscape for the sage steppe biophysical setting. Now, remember that we do not calculate departure for ag, barren or sparse, water, developed, ice, snow. There's certain classes that we take out. And so I want you to filter in your pivot table so that you only have the classes that will calculate vegetation departure for. Okay, so again, if you're here in the upper right of your Excel spreadsheet under the pivot table fields, LANDFIRE S-class, you can use this little drop down. Okay, and I'm gonna unselect agriculture, barren or sparse, and developed. And notice over here in our table that we now have our reference states, A, B, and C. We have uncharacteristic and uncharacteristic native, and we have a sum of count. But we want the percent. So go over here, bottom right, for values, and for sum of count, click the drop down, go to value field settings. So we're under sum of count, value field settings, show value as, and we're going to show value as percent of column total. And once you've done that, you can click OK. And this is it. This is current conditions on this landscape. You see that they sum to 100%. So that's important that we took out ag, barren, because that did occupy some of the landscape. But we're saying of the things that we're going to calculate departure for, these are their percents. Okay, so going back to the big picture, you've now calculated current S-class percent. So we are just one step away from calculating departure, which we'll do in the next lesson. But there are a few more things to talk about here. I'm going to stop sharing and just look at the chat for a minute. Yeah, Louis made an important point. In this particular biophysical setting, UN can often be depleted sagebrush, which is when you've lost your understory, your herbaceous understory. And we kind of get at that with calling high cover of shrubs uncharacteristic. We don't actually have a sense for the sage understory in our mapping. Okay, there are a few issues that I want to discuss. I'm going to discuss 3 issues with succession class mapping. The first thing to think about is the uncharacteristic state. And uncharacteristic exotic is usually pretty easy. Anything that maps as an exotic vegetation type could go into the UE uncharacteristic exotic category. UN or uncharacteristic native can be a little trickier. So I'll give you an example of a situation I've run into out here in the Northwest. For dry forest landscapes, sometimes people will say that if you get above a certain cover threshold, they'll call it uncharacteristic native. For example, greater than 80% tree cover might be considered uncharacteristic native in a dry forest. And what that says is that under the reference condition, you would not, period, full stop, you would not find trees greater than 80%. And so another way to look at that could be that instead of saying it's uncharacteristic, maybe it happens, but it's just really rare because you would have had in most places a very active disturbance regime. Maybe you allow up to 100% cover in your late closed state. And then if you map a lot of that late closed state, you show departure because you have a lot of that state on the landscape, not because you've forced it into departure as uncharacteristic. So either of those are appropriate options. I'm just flagging it as something to think about in your rules. And with uncharacteristic native, thinking about, will this never happen? And in which case it probably is uncharacteristic native, or is it possible? And then you do maybe want to allow for it in a reference state. And if there's too much of it on the landscape, like late closed forest out here in a lot of the West in our dry forest systems, then you're just going to map too much of that state. And that's going to show departure when you overmap late closed. Okay, that's issue one, uncharacteristic. The next issue that I want to flag is mappability of the classes. So you noticed when we looked at the succession class mapping rules that we had some rules for 0 to 10% cover, but we actually don't map it. So we're not using those rules, but you could on your local landscape. Some other things are difficult to map using LANDFIRE's methods. Mapping height of herbaceous systems with Landsat imagery is difficult. So you might consider that when you're defining your successional states. Do you want to have different states for different herbaceous heights? Or would you be safer and map states more reliably if you relied on cover instead of height? So it's really critical to know what your project is going to be able to map in advance, because you probably don't want to define states in your model that can't be mapped if you want to calculate vegetation departure spatially. If you're not mapping states, then it's not as critical. If you're just maybe going to go out on the ground and do an inventory and you can see the difference between your vegetation states, it might not matter. But if you're going to map it, it's good to know up front what you can map and what you can't map and define your states accordingly. And you'll get a better, more reliable current condition map and therefore a better estimate of departure. Third thing. Okay, so we discussed uncharacteristic, we discussed the mappability of the classes, and the third and final thing that I wanted to cover here is compounding error. I will reshare and remind you that successional states are mapped from a combination of 4 different spatial layers. And so you inherit the errors present in all these layers when you go to map the successional states. And so there is an issue of compounding error when you map succession class, and it's something to be aware of, and aware of sort of the capabilities and of these different layers, because it will influence your resulting departure. Take-home messages, we're going to have time for questions here or a short break if there are no questions. The rules really matter. And you need to think about what's mappable when you're modeling if you have to map state classes and you want to measure departure and map those states. Some things are hard to map. And so I'll just ask that rhetorical question. If you can't map it, should you model it? That's always something to think about in this type of work. The last thing I want to point out is that I do have some resources here on this last PowerPoint slide, which if you can get to the box files, You'll have these links. We have an old guide on how to map successional stages using LANDFIRE products. It goes through the process that we went through today, so that might be a good reference for you. There's also a README file with the succession class mapping rules. When you download those, excuse me, when you download the mapping rules, there's a README file that comes with them that also has some really good explanation for this process. And then there's this guide that John Helmbrecht and I wrote a while back, Reviewing and Modifying LANDFIRE Spatial Products. It's a good overview reference for all of the input layers for succession class mapping, and just a good general reference. Yeah, let's open it up for questions. Louis.
Two things. You were talking about, that more than 80% tree cover example, it was a fictional example you gave there. The reason why you may not want to put too many trees into like a late successional reference class, you were saying you could just increase the number, is in some systems, the more than 80% may be the result of past logging. So for example, you don't have any more ponderosa pine, you just have white fir, Doug fir, and things like that. And in terms of management, you may want to single that out as an uncharacteristic class, because you're probably going to have to cut and plant ponderosa pine. I'm simplifying here, because it's usually a case where the ponderosa is gone for some other reason, and that's usually past logging. So this is whoever's modeling or doing this have to think carefully about their management objectives when they make these decisions about, is it really an uncharacteristic class or is it a reference class? If it's a reference class, by definition, ponderosa pine should already be there. You just have too many other trees. But it's more than 80%, it's often that it's no more ponderosa pine. So you want to think about that. And the other thing,
could I just add to that, Louis? If you could actually map the individual cover types and know that you had shifted towards firs, the grand fir, Doug fir, that you had shifted the composition, that would be the ideal, right? So then you would have species composition proportions to inform what goes where. So that would really be ideal.
Yes. With your local knowledge, you could do that. But if you're a manager, you have to think about that, because it has consequences on what you're going to do next when you're going to ask for millions of dollars to do something or whatever. The other thing, so I have, as you know, I struggle with this all the time. You had in the examples you're giving at the very beginning, so your sagebrush steppe, but then you had as existing vegetation, Great Basin, pinyon, juniper, woodland, or something like that. And I had a similar problem where I had gazillions of acres of sparsely vegetated in the same geography. So we were doing a 120 million, and let's say there was 5 million acres or 1 million acres of sparsely vegetated. However, there was about a third of that was fully vegetated in the existing. There was 30% tree cover. So there was a complete mismatch between the biophysical setting and the actual existing vegetation. When you have a small area, you can kind of retrofit that, but it's really hard to retrofit when you're working at large landscapes. And the question is, are you guys ever going to try to fix that? For example, if you have things like black sagebrush, low sagebrush, and a sagebrush system is supposed to be sagebrush something else, it cannot be 1125. You have to go change your biophysical setting, because low and black sagebrush are tied to unique soils. So it means that you classified wrongly the sagebrush steppe in the first place. And so it's some cases it may not be, but there's just some rules, especially in the Western US, where you can go and retrofit your biophysical setting, because we're talking about millions of acres of things where the existing vegetation type has absolutely no relationship to the actual biophysical settings, because they were done very differently. And I'm wondering if someone could comment if that problem's ever going to be fixed, because you even had that problem in the data you showed us, but you're working at a small scale there, so you can kind of wing it. But we're struggling with this kind of stuff all the time. So.
Yeah. So okay, let me just see if I summarize correctly and understand. What you're seeing in the data is a mismatch or an illogical combination of the biophysical setting and the existing vegetation type. Is that right?
Yeah. And we're not talking about 5 acres. We're talking about millions of acres. Of yeah.
It's really difficult.
I don't know what to do with that, because I'm stuck with something is called biophysical setting sparsely vegetated, and let's say there's 1 million acres of it, and 100,000 acres of it is 30% tree cover in your own data, and it's either sparsely vegetated or it's a woodland, and it's called pinyon juniper woodland in the existing vegetation. So obviously there's a disconnect there. And
wait,
I was
so
wondering
the biophysical setting is sparse, but the existing
sparsely vegetated, yeah, it's supposed to be basically rock, less than 10% anything herbaceous on it, or anything or shrubs, but yet the existing vegetation says there's 30% tree cover. And you go look on Google Earth, and sure enough, there is 30% tree cover. So the biophysical setting is, and the question is that the biophysical settings were done differently, and they were kind of left behind, and all the effort and the data goes into the existing vegetation type. But one day someone's going to have to go back and fix them. And that's the question. Is that going to happen?
Yeah. So a couple of thoughts. One is that barren and sparse and rock is supposed to align between the spatial layers. And so at one point in LANDFIRE, it should have matched between BPS and existing veg, what was barren or sparse. So I kind of like to take a look at that. There has been a little divergence sometimes where things don't match. And we're trying to rectify that and get it back to the point where you're looking at this, if it's barren or sparse in existing veg, it should be barren or sparse in biophysical setting.
But I gave an example. It's not just that. It also applies to fully,
other combinations.
It says it should be montane riparian, and you look and it's black sagebrush and existing. That's not possible. Yes. You cannot have that. That needs to be fixed at some point.
Yeah, there are compounding errors for sure. So you inherit all the errors from those from each layer. And so you get illogical combinations of the existing vegetation type and biophysical setting. And that is one reason that we don't rely very heavily on type to classify successional classes. Notice that most of the work we did in this exercise, we were classifying by cover and height. We looked at the life form cover and height. I have no way of sitting here in Bend and knowing, is it the biophysical setting that's wrong, or is it the existing vegetation type? So it's really hard. It's really messy. Okay. I didn't expose all of those extra rows for our exercise because I wanted people to focus on the process, but it's true. You'll get illogical combinations of things, and you just find yourself scratching your head when you're trying to S-class them. So we fall back on primarily cover and height to map. And then to the question about remapping BPS, we very much want that to happen. And we have been trying to build the case for the program to do that. And I don't think there's a commitment at this point, but we hope that at some point in the future, they'll do that. Jim, can you add?
I can try to, Louis. Yeah, it's been recognized for a while, basically since day one, that there were things about the BPS that needed to be modified, that needed to be made better. And we've actually collected data from different places, like from Tom DeMayo or Hugh Safford or Steve Simone or others, in preparation for doing this. So we need to hear about that from people and say, you can't say outside of Ogden, you've got black sagebrush wrong. You have to give us something that we can actually use in a refinement process. Okay, so we have been making a case for this. It has not passed muster to this point, but I think this renewed interest in departure, fire regime condition class, et cetera, that we are now seeing may provide the fuel we need to actually get this done. It won't be a complete remapping of BPS, but we can refine BPS and make it better through feedback that we get from people like you, Louis, and others that have provided that to us. That's probably the best that we can hope for. Not a remapping, but a refinement of what we have and making it better.